Welcome to Excel 2010 Statistics video number 45. Hey, if you want to download this workbook, Business 210 Chapter 5.xlsm, click on the link below the video. Hey, we're on the sheet PD2 for probability distribution 2. Hey, we're going to see how to build a discrete probability distribution. The steps are right here, 7 steps. We first need to define our random variable, build a frequency distribution. Oh, we learned that in Chapter 2. Create relative frequency. We did that in Chapter 2 too. Check the 2 requirements, 1 and 2, for discrete probability distribution. And then we're going to create a column chart for a discrete variable. That'll help us visualize the distribution and then make distributions. Now, this example here is not done from raw data. It's like a problem from the textbook. So here's our problem. Over the last 20 days, the number of operating rooms used at TG Hospital were, on 3 days, only 1 were used. 1 used meaning the operating room. 4 total operating rooms. And on 3 of the days in our sample of 20 days, 3 of the days, 1 was used. 5 days, 2 were used. 8 days, we used 3 operating rooms. And on 4 days, all 4 operating rooms were used. So our goal is to create a probability distribution that can be used to make predictions in the future. Now, step 1 is to define the random variable. So random variable means, like, if we're looking in the future, on any given day, how many operating rooms could be used. So it's not days. It's the actual number. 1, 2, 3, or 4. Or it could be 0 either, but we don't have any data that shows that we had 0 rooms used. So the discrete random variable, remember, discrete just means like counting, or the numbers have gaps. So we're going to write it right here. This is the number of operating rooms used in 1 day. So that's going to be our discrete random variable. Now, the next step is to build a frequency distribution. Now, here we're given the data. They're given a kind of like a written problem. If we had the raw data, right, we would count. So on day 1, we would count 3 rooms were used. On day 2, maybe we counted 1 were used. On day 3, maybe there were 3 were used. So we'd have a list of 20 numbers, right? This is already somewhat summarized for us. So we can simply take these numbers. But before we count our frequency, we want to list over here our number of operating rooms used in 1 day. Now, from our sample here, we had 1 to 4. So we're going to put 1, 2, 3, 4. Now, normally we put our variable over here, and then we counted frequency to the right in our last videos. But we're going to make a chart from this. And I want the random variable here, and then the relative frequency over here. And then we're going to make our chart. All right, so here's where I'm going to put our frequency. All right, how many days did we have 1 operating room in use? 3. That's our frequency. 2 operating days use, we counted that on 5 times that occurred. 3, there were 8. I'm just looking up here. And finally, all 4 rooms were used on how many days? 4. So that's the frequency right there. Now let's add up all of these frequencies. We better get 20. Now we have our individual counts for each random variable here, and our total. Now we can calculate relative frequency. So we're simply going to compare the parts to the whole. That's a relative cell reference divided by the total, and I'm going to hit the F4 key. Control Enter, and then copy it down. Now let's add this up, and it better equal 1. All right, so it does. That meets requirement number 2, that the sum of all of the probabilities equals 1. I'm also going to check here to for requirement number 1, that each one of the probabilities has to be greater than or equal to 0. Now, I can eye this and see, but sometimes you never know. I love these logical formulas in Excel because sometimes they catch things, because Excel doesn't very rarely makes a math or logic error. But we, as humans, with our eyes and stuff, make errors all the time. So I'm going to put that formula right there. That'll work all the way down. That's a logical formula that gives us a true or false. Right? We could test this -1. And then I'm going to Control Z. All right, so our 2 requirements are met for our discrete probability distribution. This is, in essence, a tabular form right here. But let's make a chart. Absolutely, going forward in this class, we're going to be using probability distributions all the time. And visualizing them with charts is quite handy. All right, so we have what we want on the horizontal axis, and then the height of our columns is going to be the probability. Oh, yeah, we already saw this in chapter 2. We did histograms. But remember, when we did histograms, the categories were touching. There were no gaps. Here, there's gaps between 1 and 2. And so we're going to use a column chart. But we're definitely not going to let the columns touch. And actually, back in chapter 2, I showed you, if not this exact chart, one very similar from chapter 5 when we were doing categorical data. Because with categorical data, you're just counting a category, and you don't want the columns to touch. But when you have numbers and there are gaps, you want to visually leave the gap. So let's see how to do that. I'm going to highlight these 2 columns. Go up to Insert Column right there. Or we could use our keyboard shortcut Alt F1. That is a keyboard shortcut in 2007 and 10 that creates the default chart on the current sheet. We talked about that before. By all means, go up to Insert Column. Now, this chart, and we talked about this back in chapter 2, charts don't always get things right. And here's the problem. When you do a column chart, it's expecting a categorical a category here, which is in essence is a word, and then a number here. As soon as it sees 2 numbers, it puts both of the numbers on the chart as column height. So of course, the very tall ones, this 4 is the blue one, and then the numbers between 0 and 1 here are very small. The second problem with this chart is that this axis here showing these numbers, they're actually not coming from here, and I'll prove that to you. If I type a 0 here, right, you can see that goes away, but these don't change. Those come by default when you don't give it words to display there. I'm going to Control Z to undo that. So 2 things. I'm going to click on these columns, delete. Oh, I can see the distribution already. While I'm at it, I'm going to delete these lines too. And I'm going to delete this. Now, to fix this, we go up to Design. And this is the most important button when it comes to charting. We've seen it a bunch in this class so far. I'm going to click this. And this gives us the power. We can do whatever we want. So now we have that. I'm going to come over to Edit. And there it is. You can see there was nothing there. It just had those numbers by default. And now I'm going to highlight these numbers. These are the discrete numbers we want on the horizontal axis. Now remember, those were phantoms. They weren't really there. And I proved it to you by putting that 0 there and seeing that it didn't update. So now let's click OK. You could see those there. Click OK. Now, it looks exactly the same. Nothing changed. But if I were to change this to 0, well, there it is. That will be very important because we're going to do a bunch of charts for our probability distributions. And a lot of them will start with 0 or some other number. All right, Control 0. Control Z. All right, so now we have our distribution. Let's do a few more things here. I want to link this right here. And the label I want is in cell A1. So I'm going to click here, click up in the formula bar, equal sign, click in A1. Enter. Right-click this label and go up to the mini toolbar. something like 12, I think. I'm going to go up to Chart Tools, Layout. What I'd like to do, let's think about this. A couple more things to before we add any, I was going to add a data label. Let's make sure we add labels here because it's not clear what those are, and here. So I'm going to go up to Layout, Axis Titles. I'm going to go to Horizontal, Title Below. And here, this is our x random variable, a discrete random variable. So with that selected, I'm going to go up to the formula bar, or you can hit the F2 key, and that jumps the cursor up there. Type in equal sign and click on B8. Oh, I could have had a B8. Enter. So there we have that. And then let's add something for this. Vertical. And now, we can either click up here and type a word if we want. I just want the word probability. Or if it's highlighted, you can just start typing. You can already see that it automatically defaults up to there. Probability, enter. Now, let's click on the columns. Now, for discrete probability distributions, oftentimes we are going to want all of the columns to have the same color. Or we're going to want to have a certain group, like less than or equal to 2 a certain color and all the rest a different color. So oftentimes we'll group these columns into 2 colors. Right now, if it's just showing the individual ones, you could do that trick we did before when we added a different color to each one just to spice it up. Now, with this column selected, Control 1, and you can go to Fill and vary colors by point. Now, let's show some probabilities above the top of each column. We go to our Layout and then Data Labels, Outside End. Now we don't really need this, so I click here and delete. And there we have a visual portrayal of our probability distribution. Right? So with these are relative frequencies, right? We calculate from past data, but we can use this to estimate now something in the future, right? We learned last chapter the relative frequency method is to take past data and then create some probability to estimate for the future, right? So if we're planning for this hospital, right, 40% of the time we can estimate that 3 rooms will be used. 20% of the time, all 4 rooms will be used. From our sample of 20 days, we had, or over the last 20 days of the operating use, right, there weren't any days where we had 0. All right, now I'm going to scoot this over to the side here. And now we want to scroll down here. And so what is the reason that we'll do this whole distribution right here? And the reason why is because it's easy to make predictions. And we'll see that going forward especially. Now, once you have this set like this, you can answer a bunch of questions, right? What is the probability that we'll have less than or equal to 2, less than 2, greater than or equal to 2, or even greater than 2? Now, let's see the longhand way, and then I'll show you a slightly different way. What's the probability of less than or equal to? But we already have it here, right? We can literally come over to our random variable and say, well, less than or equal to, that's equal to, that's the only number less than. Those are the 2 numbers. But here's the probabilities. You just add them. There is no overlap here, right? So you just add. So we can say Alt equals is the keyboard shortcut for AutoSum, and then highlight those 2. So 0.4 less than, or probability that we'll have less than or equal to 2 operating rooms used on any day. Now, how about less than 2? Well, there's only one, right? How about the probability greater than or equal to 2? Well, here, oops, Alt equals for our auto sum. There's the 2, and that one is included here, so we highlight all of these. Another way to interpret this one right here is you could say, hey, what's the probability that we'll have more than one room in use? Well, it's 0.85, right? So based on our past data, there's only one here. So we add up all of these, including the 2, and that's the probability that we'll have more than one room in use. Now finally, what is the probability greater than 2? Alt equals, and it's just these 2 right here, not including the 2. Now, another convenient way, instead of doing each one of these by hand, you can actually use what's called the SUMIF function. Now, we've already learned how to use the COUNTIF function. Actually, we've used it a lot. SUMIF is just, there's one extra step to it. We're going to tell it, please go, for this example here, we'll say greater than or equal to 2. Well, we'll have to tell the SUMIF function, here's our criteria, but we'll have to say, hey, SUMIF function, where are you going to look? Well, you're going to look through here and find all the instances where it's greater than, or I'm sorry, less than or equal to 2. So it's these 2. So we'll tell the SUMIF function to look through this whole column. There's 4 cells. Here's the criteria. It'll look through all 4. It'll get true, true here. Then we'll give the SUMIF function a parallel range here. And it will, from those 2 trues, know to add those. So let's see how this works. Equals the SUMIF. If I could only type SUMIF. And there's a range, criteria, and sum range. Now, sometimes it gets confusing because range, you're like, oh, wait, what is that? Is that the range with the criteria? Or is it the range with the values we want to sum or add? So, and that you start off with that one, so sometimes you get confused. So the way you do SUMIF is you always look to the end and go, oh, yeah, that's the sum range. So this must be the criteria range. So I'm going to highlight this. And I'm going to hit the F4 key because we're going to copy this down. That's the range with the criteria. Comma, here is the individual criteria that will determine the adding. And I'm going to use a relative severance, 1, 2, 3, 4, 5. I like to put the operator and the number directly into the cell instead of hard coding into the formula in this particular situation here. We saw earlier with the COUNTIFs, because we had formulas that were creating labels and that were counting with criteria, then we separated those out. But if at all possible, when you put it here, then it's easy. Then you just change it in the cell. Then you have the option to change the operator or the comparative operator or the number. All right, so I have that there, comma, and then the sum range is this. F4. Close parentheses. So that formula will work. Control Enter. So that was a little bit easier than calculating each one individually. In addition, the real advantage of this is when you have it set like this, you can change this to whatever you want. Oh, I got too fancy there. Greater than or equal to 3. I'm sorry, less than or equal to 3. So we get a 0.8, right? We can type in 4, and it will calculate tell us the probability of exactly 4, right? 0.2. We could also do less than 4. Right? So this SUMIF is convenient. If you have a bunch of probabilities, you put your criteria and numbers into cells, and then you can copy down the column just like that. Or you can just build one and then change your comparative operator and number together, and boom, it will update. Now I'm going to Control Z, Z, Z. All right, so in this video, we saw how to create from a written statement our frequency distribution with relative frequencies, list our random variable. Actually, step 1 was to decide what the random variable was, then build our frequency distribution with relative frequencies. We saw how to build a chart, and then we saw how to use our frequency distribution with relative frequencies, which now we call probabilities, to make some predictions. All right, we'll see you next video.